In one of my other videos, we looked at rational or fractional indices of the form a to the power of 1 on n. If you haven't already, you should probably watch this video first. In this video, we'll look at rational or fractional indices of the form a to the power of m on n. Remember from my video on rational indices of the form 1 on n that a rational number is a number that can be written like a fraction in the form p on q, where p and q are integers. Rational indices have a rational number with p on q as the index exponent or power. The index laws can be applied not just to integer indices, but to rational indices as well. We've already had a look at rational indices of the form 1 on n. A rational or fractional exponent can have a numerator other than 1. So what happens in this case? We already found that 5 to the power of a half is the square root of 5. If we have 5 to the power of 2 on 3, we can rewrite this as 5 to the power of 1 on 3, all to the power of 2 using the power raised to another power index law. This can be rewritten as the cubed root of 5 raised to the power of 2. We also found that 7 to the power of 1/3 is the cubed root of 7. If we have 7 to the power of 2 on 3, we can rewrite this as 7 to the power of 2 all to the power of 1 on 3. Using the power raised to another power index law. This can be rewritten as the cubed root of 7 squared. When dealing with indices of the form m on n, it's often easiest to write the base number as a prime raised to a power, then simplify the result using index laws. From above, we have shown that a to the power of m on n is equal to the nth root of a to the power of m, which is equal to the power of m to the nth root. Let's look at some examples where we evaluate without a calculator first. We have 27 to the power of 1/3. We can rewrite this as 3 to the power of 3, all to the power of 1/3. And we have a power raised to another power, so we multiply the powers and we get 3 to the power of 3 on 3, which is 1, which is 3. We have 16 to the power of 3 on 4. We can rewrite this as 2 to the power of 4, all to the power of 3 on 4. And now again, we have another power raised to another power. So we multiply the powers. We get 2 to the power of 12 on 4, which simplifies to 2 to the power of 3, which is 8. And we have 25 to the power of negative 3 on 2. We rewrite this as 5 squared, all to the power of negative 3 on 2. And we multiply the powers. We get 5 to the power of negative 6 on 2, which is 5 to the power of negative 3, which is going to be equal to 1 on 5 to the power of 3, which will be simplified further as 1 on 125. Now we're going to find some powers of a prime number. Remember, a prime number is a whole number that cannot be made by multiplying other whole numbers. So we have square root of 27. This is equal to 27 to the power of a half, which is equal to 3 to the power of 3 to the power of a half. And we multiply the powers and we get 3 to the power of 3 on 2. Now we have 1 on the fifth root of 64. That's good. We can rewrite 64 as 2 to the power of 6. And we rewrite that again as 2 to the power of 6 all to the power of 1 on 5. And we multiply the powers and we get 2 to the power of 6 on 5. And this simplifies to 2 to the power of negative 6 on 5. Now we have the cubed root of 49. This is equal to 49 to the power of 1/3. And then we have 7 times 7 is 49, so 7 squared, all to the power of 1/3. And we multiply the powers. We get 7 to the power of 2 on 3. Finally, we're going to write some expressions in index form. So we have the cubed root of 13 squared. So we can rewrite that as 13 squared to the power of 1/3. We multiply the powers and we get 13 to the power of 2 on 3. Now we have the cubed root of x to the power of 6. We write x to the power of 6 to the power of 1/3. We multiply the powers and we get x to the power of 6 on 3, which is equal to x to the power of 2. Now we have 5 times the fifth root of x to the power of 5. X to the power of 5 to the fifth root is going to equal x. So we end up with 5x. Now we have the fourth root of 3x to the power of 5. We can rewrite this as 3 times x to the power of 5 all to the power of 1 and 4. And we can take that one step further. We've got 3 to the power of 1 and 4, and we multiply the powers for the x, and we get x to the power of 5 on 4. And that's it. Thank you.